Hello, students. Let's wrap up today's work by looking at some equations. Equations are very important in algebra. They show up in every algebra math class that you'll ever take. Now, you might look at these equations and go, hey, I can do some of these in my head. Let's try a few of them, just by observation. Can you think of a number that you can add 6 to and end up with 27? I can do that one in my head. How about number 2? Can you think of a large number that when you subtract 8 from it, you end up with 3? Number 4 is especially easy. Can you think of a number that you can multiply times 5 and end up with 20? Now here's the thing. You know there are harder problems coming that you can't do in your head. So while these maybe we can do in our head, we've got to be able to show our work so that we're ready for the more difficult problems coming up down the line. There are 2 things to keep in mind when we're solving equations. One of them is the usefulness of inverse operations. Addition and subtraction, those are inverse operations. One is kind of the opposite of the other. Same with multiplication and division. Those also are inverse operations. One is kind of the opposite of the other. We'll use inverse operations often. The second thing to keep in mind when solving equations is to think of the equal sign as a fence. And we can do anything we want on one side of the fence, so long as we match it exactly on the other side of the fence. So if I'm going to show my work on number 1 to find out what m is equal to make this true, well, when I'm done, I want to have m by itself on one side of the fence and the answer on the other side. How do I get m by itself over here? Well, I must get rid of the 6. The 6 is being added. What's the inverse operation to addition is subtraction. I'll subtract 6 from this side. But if I subtract 6 from this side, I must match that by subtracting 6 from this side. Now 6 minus 6 is 0, plus m is m. And 27 minus 6 is 21. 21 is my final answer. I'll circle that. How do I know 21 is my final answer? Because if I were to plug it in back here, 21 plus 6 is 27. Let's try the same game on number 2. Think of the equal sign as a fence. I can do anything I want on one side of the fence, so long as I do the same thing on the other side of the fence. What I'm looking for is a number that I can subtract 8 from and end up with 3. I know that I'm finished when I have x by itself on its side of the fence. To get x by itself, this 8 has to leave. The 8 is being subtracted. What's the inverse operation to subtraction? The inverse to subtraction is addition. I'll add 8, but if I add 8 to one side, I must add 8 to the other side. Now watch what happens. On this side, negative 8 and positive 8 is 0, and 0 plus x is x. On this side, 3 plus 8, that's 11. There's my answer. X is 11. How do I check that answer? I take that 11 and plug it in here. 11 minus 8, that equals 3. In problem number 3, the variable, y, is on this side of the equal sign. I'm supposed to find a large number that I can subtract 2 from and end up with 11. I can do that in my head. But if I'm supposed to show work, well, when I'm done, I want y by itself on its side of the equal sign. My answer will be over here. To get y by itself, this 2 has to leave. The 2 is being subtracted. What's the inverse operation to subtraction? Is addition. We'll add 2 to this side, but if I add 2 to one side of the fence, I must add 2 to the other side of the fence. Now, -2 and +2 is 0 plus y is y. 11 plus 2 is 13. Let me circle my answer. But if I take 13 and plug it in, it checks out great because 13 minus 2 is equal to 11. For number 4, I'm looking for a small number that I can multiply times 5 and end up with 20. When I'm finished, I'll have C, the variable, on this side of the fence and my answer on the other side of the fence. To get C by itself, the 5 must leave. But this time the 5 and the C are being multiplied. What's the inverse operation to multiplication? The inverse to multiplication is division. I should divide by 5. But if I divide one side by 5, I must divide both sides by 5. Now 5 divided by 5 is 1, and 1 times C is C. That's what I wanted. 20 divided by 5, that's 4. There's my answer. C is 4. If I want to check it, I plug 4 back in for C. And 4 times 5, that is certainly 20. For number 5, here's my fence. When I'm finished, I'll have my variable in on one side of the fence, my answer on the other. In order to get in by itself on this side of the fence, I must get rid of this 7. Now the in and the 7 are being divided. What's the inverse to division? The inverse to division is multiplication. I should multiply both sides by 7. That way, 7 divided by 7 is 1 times n is in, and -3 times 7 is -21. Great answer. -21 is the number that when I divide by 7, I end up with -3. These problems are similar to the first 5 problems that we did, except these have more negative numbers in them, so they're more difficult to do in your head. As they become difficult to do in your head, well, that's where showing the steps becomes very important. To solve this equation means find the number that I can plug in for the variable m that makes this true. When I'm finished, I'll have the variable m on one side of the fence and the answer on the other. If I want to get m by itself, well, this 5 must leave. The 5 and the m are being added. What's the inverse to addition? Subtraction. I'll subtract 5 from each side of the fence. That way, +5 and -5 is 0. 0 plus m is m. And when I add -2 and -5, well, when I add two numbers that have the same sign, I add and keep the sign. Perfect. Let's try number 7. I'll think of the equal sign as a fence. Now, you don't have to draw the fence in. The fence is something I draw in, but it's really just kind of in my head, I guess. When I'm finished, I'll have the variable on one side of the fence and my answer on the other. To get x by itself, the 7 must leave. What's the inverse to subtraction? Addition. And if I add 7 to one side, I must add 7 to both sides. That way, -7 and +7 is 0 plus x is x. And here, when I add -5 and +7, if I'm adding and the signs don't match, I subtract and take the sign off the larger number. Perfect. Number 8. You don't have to draw in the fence. I like to draw in the fence. When I'm finished, I'll have my variable on one side of the equal sign, my answer on the other. To get y by itself, this 3 must leave. What's the inverse to subtraction? Addition. Add 3 to both sides. That way, -3 and +3 is 0 plus y is y. And here, when I add a negative and a positive, if the signs don't match, I subtract, take the sign off the larger number. Great. For number 9, I'd like to have x on one side, the answer on the other. To get x by itself, this -6 must leave. The -6 and the x are being multiplied, and the inverse of multiplication is division. We'll divide both sides by -6. That way, -6 divided by itself is 1, and 1 times x goes there. 18 divided by 6 is 3, and when I divide with one negative, my answer is negative. For number 10, I'll end the problem with my variable on the left side of the fence and my answer on the right. To get in by itself, the -5 must leave. The -5 and the n are being divided, and the inverse to division is multiplication. So I'll multiply both sides by -5. That way a -5 here divided by a -5 here is 1. 1 times n is n. 2 times 5 is 10. And when you multiply two negatives, you get a positive. That'll be +10. All right, your turn. Make sure you copy down the problems and show your work just as I've been doing in the video. I enjoyed working with you today. Get that homework turned in. You're doing a great job.